Meteors and meteorites. So let's get our information correct first of all. So meteors are little tiny things that blow up in the atmosphere, and you've seen it before. They come to the atmosphere at really, really high speed. We're talking about something like 20,000 miles, 30,000 miles an hour. So forget about you speeding in the freeway. This is 20,000 miles per hour. And when they do, they're about the size of sand, maybe something like that, maybe a little bigger. Sometimes they're about the size of grapes. So when they come in, they immediately explode. And the light that you see, you see like a little trail in the atmosphere. The light that you see is really the air itself is burning. It's not anything that you can actually physically see burning. So what I'm showing you here, something that is also in your lab, except this is color. And this is a high-speed camera in Alaska showing us what they actually look like when they come in. And so when they come in, this little sand is coming at such a high speed that if it hits you, it'll kill you. One little sand will kill you, right? So it's like a bullet, like a 45 bullet hitting you, like a BMW hitting you in the freeway, like that. That's how much energy these guys have. And so immediately they're gone. There's nothing left of them. So what is there left of them? Well, there's some dust, just a little bit of dust. And this dust settles on the surface of the earth every year. There is millions of tons of this dust, right? Most of it is just in the atmosphere, slowly settling down on the ground. And then eventually this becomes meteoric dust. Now, finding them, it's not easy at all. You can't really find them. So you have to wait for things outside of the atmosphere or just in the atmosphere, like special balloons or something that can capture them. But it's extremely difficult to see exactly what these things are. One way to do it is to take pictures and use the spectrum. You get the light to see what components there is inside of whatever exploded. Kind of like CSI, when CSI, when somebody gives somebody cyanide and they kill them, then they take this stuff and they burn it, and they look at the spectrum of what they burnt, and that's how they can tell it was cyanide or it was calcium or what have you, right? There's a signature in the burnt stuff, but it has to be burnt stuff. Now, sometimes they're a little bigger. They're called Bullites, and these Bullites are beautiful. And I've seen only maybe 10 in my entire life, and I look at the sky all the time, so they're rare. They're not going to be there every single night. But if you see one, you'll remember for the rest of your life. The first one I saw was like I was 11 years old, I think, or 10 years old. And when it came down, I thought the sun came out. It was like there's this giant greenish, bluish light in the sky. And it's amazing. This is in Brazil, by the way. Let me show you another one. Look at this one here. You see that beautiful light? And when it comes on, it's just like somebody's flash went off, like a camera flash. You can see shadows everywhere. That's how you notice it, because you can see your own shadow if you're outside. Or if you're driving a car, you can see it. Nowadays, because all the cars have, not all the cars, a lot of cars have cameras. There's a lot of cases where cameras are captured. In fact, one of the things you guys are going to do, one of the research things you guys are going to do is about this cop car that saw a big one come in New York back in the 90s and hit the girl's car. So the cops actually saw it in their camera. All right, now one of the things in the class is these two pictures here. And I want to show you both of them and see if you can tell what the difference between these two is. So if I'm trying to figure out, some of these Bullites actually land on the ground, and bigger objects can land on the ground. If they come in straight through the atmosphere, like perpendicular to the ground, like like rain comes down perpendicular to the ground. If they come in like that, most likely they're going to just evaporate and become dust. But if they come in at an angle, it's possible that they actually survive the atmosphere and they land on the ground. At that time, a meteor becomes a meteorite. So that's the difference between meteors and meteorites. Meteors burn up in the atmosphere. Meteorites actually land on the ground. And we'll talk about where these guys come from too. Okay, so what is the difference between these two? Well, the direction is different. No big deal. They were also observed in different days. So what are we looking at? Let's take a look. You'll see an object here that is coming in. You also see a lot of the star trails. These star trails happen because the Earth is rotating. And so the camera that took the picture was taking the picture for like 10 minutes. So for 10 minutes, it recorded the Earth's rotation. And that's registered by the motion of the stars. You can see the stars are moving. So the stars are moving here. They're all going parallel with the Earth's equator, and you can see they're all parallel to each other too. And when this guy comes in, you can tell this is not a star. It's going a different angle than the stars. And the camera that took this picture had a shutter that opened and closed 60 times a second. All right. So you can see also that in the motion of the stars, you can see like there's a little interruption in the stars. But you can also see in the trail of the meteor. You see it? There is interruption. You see that, you guys? These are all interruptions. Okay, so by those interruptions, and we know exactly how fast the shutter is opening and closing, and the angle that the meteor is coming in, we can tell how fast it was moving. So that's a pretty cool thing, because you could possibly go and find them someplace, right? Now, let me show you the other one now. Take a look at this one. Which one of these two, you're supposed to think about this, was going faster, right? So what is the difference between these two? Let's take a look. This one, the interruptions are closer together, you see? Much closer together. Take a look. This one here, the interruptions are a little farther apart. You see, they're a little farther apart. There is a lot less interruptions here, whereas this one here has more interruptions. And you're supposed to figure this out, you guys. Now, if you can't figure it out, I would suggest the following experiment with your eyes. All right, so do this experiment with your eyes. Instead of a camera, we'll pretend your eyes are a camera. Instead of the shutter of the camera, we pretend your eyelids are your shutter. So you close in your eye, you open your eyes like this. I don't know if you guys can see me. Can you guys see me? I'm going to move the camera so you can see my eyes. There you go. That's like a shutter, right? So that's the shutter of your camera. Well, your eyes is like a camera, right? And then move something in front of your eyes, like your fist. Move it in front of your eyes and then count how many times you see it, like in 5 seconds. That's all you got to do. So you're pretending that your eye is a camera, your eyelid is the shutter of the camera, and try to close and open your eyelids, you know, like maybe a few times a second, but don't change the speed that you open up the eyelids. So go bang, 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 as many times as you can do it in a second. All right. All right, now we get to meteor showers. So meteor shower is a pretty exciting thing if you see a good meteor shower. At Southwestern in 2001, I went with the students on a field trip. So I asked all the students to go to the Enzo Borrego Desert with me and camp out at night. It was really windy, so we didn't actually camp out because our tents were flying up in the air. In fact, somebody went to sleep. Some lady came in and she was so tired she fell asleep. And her tent went up in the air about 20 feet. And she was still asleep when the tent came down. It was the most amazing thing, you guys. We had to wake her up to tell her that she was flying 20 feet above the ground for a while. Anyways, we saw 5,000 per hour. Can you imagine seeing 5,000 meteors per hour? Now, we don't call this meteor showers anymore when there's 5,000 per hour. We call them meteor storms, right? This is a meteor storm. And in 1866 it happened. I believe that Abraham Lincoln saw it. You could see it, especially, again, it happened in New York in 1966, and it was also seen. There was 100,000 per hour, an amazing number, right? We only saw about 5,000. So we parked our cars around in a circle, and we all sat in front of our cars so we can be out of the wind. And People in front of me start counting the stuff behind me. I counted the stuff behind them. So we're all counting everything in the sky. And then we called it out. We counted 5,000 in 1 hour. It was the most amazing thing I've ever seen in my life. Besides the solar eclipse and the birth of my kids. All right, well, here's one that is real. This is actual picture. The other one was a wood carving. Now, you can also see them, and it appears like they're all coming from the same direction, doesn't it? Let's take a look. Like this guy here, this guy here, this guy here, this guy here, this guy here. These have the same origin. And so if you follow these trails, they all come from somewhere up here. You see, they're all coming here. This is called a radiant. Radiant spelled R-A-D-I-A-N-T. Radiant. So these all have radiance. Now, why do they have radiance? Because as the Earth moves, we're going to encounter like a cloud of dust in the sky. Most of this dust is left over from comets. So comets come around the sun, and as they come around the sun, they have a lot of dust. Most of this dust is embedded. That means it's in the ice, because comets are just big, gigantic chunks of ice. So when they come around the sun, the ice starts going away. Now, this is called sublimation. Normally, we call it, something, the ice is just becoming liquid, right? Melting. But in space, there is no liquid. It doesn't exist in space. You need atmospheric pressure to have a liquid. So in space, there's either a solid or a gas, but no liquid. So when the ice goes away, this dust is spread out in the solar system. And then as the Earth goes through these dust clouds that the comets leave behind, then we see them entering from basically in the opposite direction of the Earth's ocean. And so they enter the Earth's atmosphere, kind of like that. You see them. Now there's another meteor shower here involved too. You can see this one here is not from the same origin, neither is this one here. Let me show you some more. Look at this one here. You can definitely see the radiant here. This is a radiant. This is the best meteor shower of the year. Happens in August 12th to be the peak, actually, because as the Earth goes through this dust cloud, it could take 10 days, a month, sometimes 2 months. And we know exactly which comets leave this behind too. There's a list of them. And I left you that list in the lab so you can see it. And we can see what's going to come in 2021. There's only a couple of really good meteor showers, and they've already happened. They're not going to really happen anything special in this spring. But in August, look out. It's the best time of the year to see meteor showers because you can go out camping too, so you can see them. There's another one, so you can see the radiant. There's a radiant is right here. Everything appears to be coming from this general direction. Do you see that, you guys? All right, radiant, all right. Now, what you haven't seen is that right at the radiant, there is some that look like an exploding dot. These exploding dots are coming right at you. And so the closer to the radiant you get, the smaller what we call the trail of the meteor. So the meteor trails are shorter here. As you get farther and farther, they get longer, longer, longer from the radiant. Close this down. Now this is the astronauts seeing a meteor shower from space. So there is atmosphere all the way, 100 miles up, but you can't really see it. When these things come in, even though the atmosphere is very thin, like the atmosphere of Mars is only 1% of the atmosphere of the Earth, it's still at this speed, there's oxygen. And what you see is the oxygen in the air itself is burning, right? You can see it from space. All right, here's another one. These are all from 1866 or 1966. Wood carvings. Another wood carving. This guy here looks like Abraham Lincoln. It could be. Must have been pretty glorious to see them. All right. This one is called a Perseid meteor shower. Now, the reason we call it a Perseid meteor shower is because the radiant happens to be in that constellation. So the radiant for the Perseid meteor shower is in the constellation of Perseus. So Perseus, we said these are the Perseids. If it comes from Scorpio, we said they're Scorpiids, like that. That's how we refer to them. All right, let me close this. Okay. Let me stop sharing that with you guys. Any questions about meteors so far, or meteor showers that you'd like to ask me, you guys?
So then these meteor showers are just us being able to see these asteroids burning up in the, not asteroids, meteors burning up in the atmosphere?
Again, they're not really the meteors themselves burning up in the atmosphere. It's the trails or the oxygen in the air burning, right? The object
Mm.
themselves explode upon the contact with the atmosphere. So there's nothing there except this ionized gas, you know, is going really hot stuff coming through.
Is this
Okay, let me see.
because is
I'm
this
sorry?
because I was just gonna ask, is this because of the speed that they're going in? Uh,
Yes.
okay.
Now, let me see. There's some notes here. I was wondering if it's more common to get struck by lightning or hit by a meteor. Meteor, no, not a, yeah, okay, meteorite. Thank you very much for correcting yourself. I like that, Victoria. Very good. Now, Giovanni says, well, I would say definitely lightning. And Giovanni says, probably. I remember there was a story about one guy who got struck by lightning 7 times throughout his life. Eh, maybe it was in his dream, or maybe he found a place where he can get struck. You know, if you have like a rod and you go into a storm, it's possible you can get struck. So maybe he was working on to get struck. There's crazy people everywhere, right? They're trying to get struck by lightning. Ah, all right. Now, meteorites is when they actually land on the ground, and these are exciting. Why are they exciting? Because there is money involved, right? These things are more expensive than gold. So when you find it, you can sell it. Where do you sell it? Well, you sell it nowadays. I guess there is no more gem show in Las Vegas, but normally there's a yearly gem show in Las Vegas for people to bring their beautiful rocks, like geodes and stuff like that, and they sell it. And these people also have meteorites. There's some meteorites people that just go around collecting meteorites, right? I'm going to show it to you. And these people go long ways. They go to Africa, they go to Sahara looking for meteorites. Every day, 24 hours a day, they're just driving around like a, Toyota truck looking for meteorites. And when you find one, you're most likely going to find many meteorites, right? And so, because they land and they kind of blow apart, so you can find maybe 1,000 pieces in one place. That's how they get rich. And this guy's made millions of dollars. They call them meteorite prospectors. Isn't that a cool name? Prospecting for meteorites instead of gold. So this is the best place in the world to find meteorites, you guys. This is the South Pole, Antarctica. It's a continent. North Pole is not a continent. It's just ice on top of the ocean. So this is a continent. This is a big giant continent. And India and Australia used to be stuck to it. And eventually they moved away, I think about 60 million years ago. So these guys here are scientists. They go to the South Pole. And I believe something like 60 countries have little places there. You have to have permission to go there. You can't just go to the South Pole here. So these guys take the, what do you call these motorized ice vehicles, snowmobiles? They take these snowmobiles with a pair of binoculars, and because it's ice, it's white. And the meteorites, most of the time, they're black, dark anyways. And so they take their binoculars, they look for something dark. Also, here, the ice is liquid. Even though you think ice is solid, ice is liquid and it moves. Glass is also liquid and it moves. You can see the motion of glass in ancient cathedrals. You see the bottom of the glass is very thick. The glass from the top kind of flows down to the bottom of the glass. So next time you go, take a look at these ancient cathedrals, like a church. Now here, the ice moves And as it moves towards the mountains here, it deposits the rocks that come from space, and then it turns around and deposits it right at the base of these mountains. So all you got to do is to get a job here, maybe as a cook or scientist. If you finish your your work, you can go there as a scientist and look at the base of the mountains and find them. Unfortunately, if you bring them back, it's illegal. You have to send it to Smithsonian or some other institute. So if you go to Smithsonian, to the basement of the Smithsonian, I believe nobody's ever seen it, I don't think, except for people that work there. I think there's thousands of tons of this stuff worth of billions and billions of dollars sitting at the basement of the Smithsonian in Washington, D.C. All right, this is what they look like. So this guy just found one. Piece of cake. Then they take pictures, they put little size things on them so you know exactly how big they are. Sometimes they find things like amino acids inside. And these amino acids are the basic building blocks of life. And we also think we found life inside of some of these, and I'll show you the evidence for life. All right, so this is how the ice is moving. This is the motion of ice. And then the wind basically erodes this ice, and you'll be able to see this stuff at the base of the mountains here. That's where you want to go. You want to go to the base of the mountains. All right, now this one here is from Arizona, the Meteor Crater in Arizona. Misnomer, right? They should have called it the Meteorite Crater, not the Meteor Crater. This is the road here, right? And so you don't want to go four-wheel driving here, because if you're four-wheel driving, you go right over the edge here and fall in. This happened a long time ago. One of the things you need to do is to figure out how old this thing is, when it happened, and what happened exactly, because this stuff is not here anymore. People have picked it up. Pieces have been picked up. In fact, I had a piece and I sold it. And then it went in deep, maybe, I don't know, maybe 1,000 feet, maybe deeper. And then it melted into the rocks. And there's a little store here. They have little t-shirts and everything. Can you guys see this little building here? It's kind of a cool place to go to if you want to go check it out. They don't allow people to go inside the crater anymore. They should, though. It's pretty fun. All right, this happened in Chicago, you guys. This is Oprah's house. No, just kidding. It's not Oprah's house. Somebody in downtown Chicago got hit. Now, when it hit, it went through the roof, hit the ground, and then it bounced back and hit the roof again. That's how much energy this thing has. So it goes right through the shingles to your sheetrock is nothing. Hits the ground and it bounces again. This guy made some money. Right, you can sell these things, but you need to sell them immediately while they're hot, warm, because that's when you check to see what's inside of them. That's exciting. All right. Now, I believe these are moon rocks. Not very big, right? This is, let's see, 1, 2, 3, 4, 5 centimeters. It's about 2 inches a piece, right? Now, these moon rocks were found on Earth. These are very expensive. I would say something like $500,000. That's what you're looking at. And I saw some of them that are actually from Mars. There are millions of them. All right, these are the meteorite prospectors in Sahara, in Africa. Nowadays, though, they quit because of what happened in Libya. So they quit. This is kind of a dangerous place. Somebody wanted to take them and enslave them and sell it to, I don't know who. So they stopped doing it. But they used to find these pieces, man. And they used to sell them, making lots of money. And they just drive all day long with these trucks and big Toyota, four-wheel drives. Yeah, pretty tough. Now, why is this a great place to find meteorites? Do you see any vegetation here, you guys? I mean, if you're driving around and you see that black rock is sticking out like a sore thumb, right? You go, oh my God, look at that. There it is. So you just pick it up. Now, this one here is the biggest one that was ever found. It also has a history. It was found by the Nazis in Africa, right? In a country called Namibia in Western Africa. It's a great place, actually, this place in Namibia. And it's 60 tons. They put it in a farmhouse. And this farmer is making money by having people sit here and giving lectures by some astronomer guy, and people can go take their pictures here on top of it too. I guess it's $5 a shot.
Is that the biggest in the world?
That's right. It's the biggest that was ever found in the world. I'm sure there's some inside
Wow.
the ground that's lodged into the earth. This is the biggest one that was ever moved, 60 tons. It's not easy to move. Yeah, the Nazis worked on it pretty hard, I guess. All right. All right, so most of the meteorites look kind of like this, you guys. Now these holes here, this is outgassing holes, right? So when they land, they're hot, 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 and they outgas, and you can see all these things. Now this is most likely metallic. Most of them are metallic. Metallic meteorites are cheaper because they're more abundant when you find them. Rocky meteorites, there's two different kinds basically, rocky and metallic. They call them iron meteorites. There's some magnesium in them. There's also questions about what kind of stuff they find in there. But these are easier to buy because when they hit the ground, they don't just disintegrate. They stay together because they're made of mostly iron, right? But the ones that are rocky, they fall apart. They're much more expensive. And so when you find them, you can make much more money. If you saw something like this, most likely it's a meteorite. Could also be a volcanic rock.
Sina, I have a question or a comment.
Yeah.
I was just gonna let you know my phone's about to die, so I'm gonna zoom in on my other phone really quick. So I'm gonna leave this one and then zoom in
don't
again.
leave yet though. This
Okay.
is the most exciting part of the lecture here.
Okay, I'm listening. I'm not.
Yeah,
Okay, I'm listening.
what we're looking
I'll
at
stay.
is possibly life. That's what we're looking at. So these are probably microbial life from Mars they found inside the meteorite, right? And they're about 1/100th the size of microbial life on Earth. So this is a much smaller than microbes on Earth. And there's still debate about exactly what these things are. It's 50-50. 50% of scientists believe it's microbial life. And President Clinton, I believe in 1986, or something, could have been 1992. You guys going to write this out? You're going to be doing a little research on this too. He went on TV and said for the first time ever we found life from outer space. So this was pretty exciting time back then. Clinton was really excited. You know, at that time we all thought that Clinton was a good president, but even Republicans used to think he was a good president. This is a rock at the Smithsonian that we think is from Mars, and it probably landed on Earth a long time ago. And so how did this end up on Earth? Well, you see a couple of different scenarios possible. Mars has this gigantic volcanoes, and when they erupt, it's the biggest volcano in the solar system, much, much bigger than Everest. And so it's like the size of state of Nebraska. That's how big these volcanoes are in Mars. Huge volcanoes. And this one volcano, this gigantic volcano, can shoot this into space. That's one possibility. Another good possibility is like the moon has been hit by a lot of giant rocks, and they make craters, like asteroids that big. Well, when something like that hits Mars, chunks of Mars flies into space, and it could eventually land on Earth, right? By the way, you guys know that when I'm doing this, I can't see your chatting, right? I can't see your chat. It's all covered up by this. So this one is worth $5 million estimated. Nobody's going to sell it. You might even find meteorites like this, right? I know this looks really weird, right? They're called, this stuff is called moldavite, like moldavite flowers here. Pretty weird.
I have a question.
Yeah, sure.
You're saying they're like really expensive, but like what is even the market for these? Like who would buy this?
Oh, did you come in late, or we talked about Las Vegas, remember?
Yeah, but I mean like that just seems like it would be like just the one facet of it. Like, is it just like avid collectors? That's it? That's all?
Yeah, absolutely. It's like you could go out there and buy one, right? Why? Because they're rare. Whatever is rare, right? Like, why do you buy gold? because gold is rare. You don't find gold in your backyard, right?
Right.
That's why you buy these two. Because they're rare, they gain in value. If you bought one of these, say 30, 40 years ago, they'd be much more expensive than gold right now. You get rich. Now, this girl didn't get rich, but I guess in 1986, $50,000 was a lot of money, right? So she was just, you know, chilling in her apartment, and this rock hit the back of the car. Ford Malibu 1984. Why do I remember? Because the trunk of the car is cut and mounted on the wall of the Smithsonian. That's why, right? She was just sitting minding her own business, and there was a football game going on close by. So the cop car picked up the actual object as it was coming in. And then this is the girl that found it. They called it Syracuse University. They gave her money immediately. And later on, she sold the back of the car too. This was a historical event. Pretty cool, huh? All right. Now, these are strone fields. Again, remember I told you that when one of them comes in, you can find others nearby? That's what a strone field is. Spelled S-T-R-E-W-N. A strone field is where you find meteorites, because one of them hits and then pieces can fly all over the place. So if you find one, don't stop. You keep looking, right? You could find another 1,000 nearby. Like this. Can you guys see this? This one broke up in the atmosphere. So if it breaks up in the atmosphere, all the pieces are going to land on the ground too. That's where most of the strone fields come from. And also when they hit the ground, they also split up into little pieces too. All right, now, when something big hits the Earth, chunks of the Earth become liquid, actually, molten, and they fly up and land in different places. Now, these pieces here are called tektites, spelled T-E-K-I, like a kite, tektite, tektite, right? So these tektites, see tektite? It's a tektite stone field, and you can find them in other places. This basically earth stuff mixed in with meteorite stuff, and these are much less expensive. And so you can find them all over the world. I have quite a few of them. I bought them from Chinese in China, and they have also gained in value. I paid something like 20 bucks for something like 50 grams. So they're not that expensive at all. And now there's something like $150 for the same chunk, 50 grams. About $3, $4 a gram, actually. So yeah. And you can find some in the United States too, in Georgia. They call them Georgiaites. You can see that, you guys? And so they have names, I guess. Australia, there's quite a few of them. Indochina, where they be called India and China, you know, basically in this area here, where Philippines is, you know, there's a lot of them there. And so they kind of look cute. Now, one of them, we don't know what it was. Something hit Russia, 1908. Have you guys heard about this one?
Was this in Siberia?
Yeah,
Is
yeah.
the power of like more than
Tunguska.
a couple
Yeah,
of
yeah.
yeah.
They're still doing research on this, right? So for hundreds of miles, trees fell down like matches, right? Look at them. Incredible explosion. They found bears in trees, on top of trees, right? Big giant bears in the trees. So it was an incredible event. But it exploded, whatever it was, it exploded above the ground. It didn't actually hit the ground. There is no crater that we can find. But there's little tiny spheroids, this black tarry spheroids that we found on the ground. And this is what a tektite looks like. Not the actual spheroids though. So tektites look like molten, right? This is the stuff that came in, hit the ground, and then splashed, including molten earth stuff together all over the place. Now you see this thing here, that's because when it came in, it got molten, and then this went inside into a hole, and so this end of it was sticking out of the ground. That's why they look like the way they do. This one is a really expensive one. This is from an actual asteroid called Vesta. It's one of the biggest asteroids in the solar system. Awfully expensive. Now, we know it's from Vesta because we've done a lot of research about Vesta. It's one of the more impressive ones. So we can actually figure out where they come from. Another way to find these is to look at pictures from space. Like with Google Maps, you know, the Google has pictures of the Earth, Google Earth. So everything is round. It's got to be a meteor crater, right? A meteorite crater. What else could it be? I can't think of anything else except for volcanic craters. That's it. Volcanic craters or stuff that comes in. Now, these guys here eventually will go away because what happens on Earth is geological activity and erosion, right? Like wind, rain, water, ice, all this stuff, you know, can destroy some of these things. But geological activity can also cover them up too, so bad things can happen. And so the Earth doesn't have as many as the Moon because of the atmosphere. The Moon doesn't have an atmosphere. They still come in here. I mean, they still come in and hit the ground. And so it's not because the Earth has an atmosphere and these things burn up in the atmosphere. The Moon doesn't have an atmosphere. They just go directly hit the Moon. It's that the Moon doesn't have erosion. The Moon doesn't have geological activity. That's why we have so many on the Moon, not that many on Earth. So I can guarantee that you guys are sitting on a meteor crater right now, meteorite crater right now as we speak. Now you've also heard of meteoroids. That's what they call them in space. So meteoroids in space, in the atmosphere you call them a meteor. When they hit the ground, we call them a meteorite. This one hit a long time ago, perhaps 65 million years ago. You guys have heard about this one? And it hit Mexico, right? Yucatan Peninsula, Cancun. And they found it when they were looking for, there's two craters. You see this outer crater and the inner crater. So there was a huge wave and also fires associated with it all over the world. Tsunami must have been gigantic. This is a time when all the dinosaurs died. And there's stuff, if you dig the ground, you can see there's dust. Very close to this area, there's a very thick dust, like a couple of inches of thick dust from that era, 60 million years ago. As you move away from this, let's say you go to North America, farther north in America, or you go to Europe, there is that layer, but much thinner layer of it. So we think this caused the extinction of all the dinosaurs. This is just a drawing. This is not real. There it is, right there. Yucatan Peninsula. All right. Now I am done with this, you guys. I'm going to look at your lab and help you guys finish the lab. Let me see real quick. Okay, right. All right, so here's your lab. Can you guys see it, by the way, or do I need to start sharing?
No, I don't see anything.
I gotta start sharing. Yeah, thank you. All right, now you guys see it. Meteors and Meteorites lab. So there's a lot of instructions here, especially when you get here, start reading it. There's not much reading, but the reading that there is, a lot of the answers here can also be done by reading this, especially this last page. There's some answers here, hidden answers. So explain the differences between an average meteor and a bullite. Does anybody remember what a bullite is? Remember I told you about bullite? Well, you can Google. Find and print a list of yearly meteor showers by using the internet. Include the list and all that. So I did that for you guys. And let me see now. Let me see if I need to have another share, or can you guys see this? Can you guys see this? Let me see. This Zoom stuff is always on my way. All right, can you guys see this or no? List of meteor showers. It says principal.
No.
No? No? Okay, good. Not good, I mean, you know. All right, so now I'll show it to you. All right, can you guys see it now? All right. So this is a list of the meteor showers. This is the ones for 2021. Normally they don't change except the number, you know, like if you go through a thick cloud or thin cloud and all that, that changes. And there's these Italians that can figure it out. Incredible. I don't know how they do it, but they do it. And so this is the name of the meteor shower where the, remember the radiant is from. Like Draconides is from the constellation of Draco, Perseid from, you know, Perseus, Aquariids, right? Lyrides is from a constellation of Lyra, Geminis from Gemini and all that, Orses from Ursa Major, like that. It tells you when is a good time to see it, like pre-dawn. Pre-dawn means like after midnight. That's the best time to find the meteor showers. And they tell you when in San Diego, when you're going to get the best days to see it. Like when they say to see it on the 12th, that means after midnight on the 11th. All right. So when they go July 28, 29, that means after midnight on the 28th. Like that. That's how you read this. And they also tell you how many per hour you should expect to see. They tell you what comet they're associated with. Some of them are unknown. We don't know. Like this is Halley's Comet. This is a Thatcher Comet. Comets are named after people that discovered them. All right, like this one here. My favorite is this one, Geminids or Gemini. We don't know where it came from. These are the brightest Bullites I've ever seen. Is really impressive. That's the one you got to go see, you guys.
Oh, excuse me.
Yeah.
I just started to look at the lab and I found my own list of meteors. Is that okay if I do? I mean, if that.
Oh, absolutely, absolutely. Yeah, no worries. Yeah. I just tried to help out.
No
In fact, if you have a better one, you can share with other people too. Yeah, no, of course. No. I would never say no to that. No,
Okay.
good thing. Now, who are you?
Noah.
Noah. Okay, Noah. Noah, can you hang around after class for a couple of minutes with me?
Yeah, I can do
Thank
that.
you, Noah. I appreciate it. Okay. Now, let me actually go over the lab because I like to go over every single question with you guys here today. All right, let me see. Share again. All right, so you remember I showed you these pictures, you guys? I showed you the difference was the number and the trail of the meteor. So the meteor in the sky has got trails because of the shutter opening and closing. So imagine the camera is taking a picture continuously. So the shutter is open, right? But you have this other shutter that closes and opens like a fan blade, right? I'll draw it for you in a second so you can see. So this fan blade is rotating maybe 100 times a second, 60 times a second. So this is the reason you have these interruptions in the trail. And they ask you which one is faster, number 1 or number 2. Now, question 4 we can't do. Question 4 is my actual objects that I normally share with the class. I give it to you guys so you can touch it, test it, and stuff like that. So you can skip question number 4. Question number 5 has to do with you guys checking this stuff out on the computer. Like the Tunguska meteorite is the one in Siberia. This is Canyon Diablo. This is the one in Arizona. Yucatan is the one in Mexico. Hoba is the one in Africa. The one that I showed you is the biggest one ever. This is the Martian meteorite that had life forms in it. This is the Peekskill meteorite that I told you about, where the girl got hit by the meteorite in her car. And then we go to question number 6. Question number 6 is asking you very simply, why is it that we see a lot more meteorite craters on the moon than we do see on Earth? So remember, we just discussed it. 2 answers. Please don't say, I beg you, don't say these meteorites burn up in the atmosphere, they never reach the ground because the Earth has an atmosphere and the moon doesn't have an atmosphere. That's why I wrote down the large meteorites would have survived the Earth's atmosphere during the entry. All right, name 3 places on Earth and explain why. To find meteorites. So I guess I already kind of gave it away, right? 2 of them you should know by now. You guys remember the 2 places that we talked about?
Mentioned Africa and Antarctica.
There you go. See, Giovanni, you might go there, huh?
I would. That'd be pretty cool just to prospect stuff. See
Yeah,
if
I
I
know,
could find
right?
anything. Yeah.
Another good place would be dry lake beds. And what you do, you take your metal detector. Remember I told you most of them have metals in them, right? So you can put the metal detector onto the ground, just walk it. I was thinking about building one with my son, like a metal detector that drives around automatically like a robot in a dry lake bed. See if I can find some. But there's a lot of people doing it. What are strone fields? Remember we talked about the strone fields. What are tektites? Name 5 places to find the tektites. And then question number 11. Remember I told you the question number 11 will be found here. It says, look at the introductory text. I told you there you're going to find the answer to why nickel content of a rock is the best way to figure out if it's a meteorite or a rock. And it's not very difficult to figure out if it's nickel content is. All right, question number 12, I'm going to draw on the board for you so you guys can figure it out by yourselves. But I'll draw it and I'll help you guys with this question. Any questions that I need to help you guys with right now, please ask me before I get on the board.
Looks good.
Okay, so you guys can just draw this diagram, and this diagram will help you do question number 12 exactly. In fact, I might just give you the answer. Okay, sorry. All right, so the question is asking, why after midnight the best time to see meteor showers? Why is that, right? Why is it after midnight? Why is time have anything to do with it, right? Let's figure this out. So we have the sun in the center of the solar system. Here's the Earth. So here's the Earth's orbit around the sun, all right? There's the Earth's orbit. So I'm going to put the
Copy
sun.
that.
I'm sorry?
Copy that.
Yeah. Right. On the sheet of paper, you can transfer it to question number 12 afterwards, or you can do it on if you want on number 12. If you trust yourself, do it just now. There's no worries. All right, so I'm going to put the sun here. Here's the sun. Then I'm going to put the Earth here. So here's the Earth. Ugly Earth, but I'm sorry. I do bigger circles better than smaller circles for some reason. All right, good enough. So this is the Earth. And the Earth has 2 sides. Always 2 sides to the Earth. Remember I told you before, there's a sun. And so if there's a sun, half the Earth is in sunlight, half the Earth is in nighttime. That's what nighttime is. When the Earth turns away from the sun, it's nighttime, right? So this side of the Earth is nighttime. This side of the Earth is in sunlight. So that's daytime. Now, if you're standing here, right? If you're standing here, what time is it if the sun is on top of your head here? 12 noon, right? That's 12 noon. All right. That's right, 12 noon. All right, so this is 12 noon. That's 12 p.m. Now, what time is it here if I was standing here? Now, which way does the Earth rotate? Now, this is the North Pole of the Earth. So we're looking down on the Earth and the sun from the top of the orbit. We're just looking down like God is looking down on the solar system. We're looking down. There's the sun. Here's the Earth going around the sun, but I'm looking at it from this angle here, like this, right? So now, here is some lady, maybe, and she will see as the Earth rotates, the Earth is rotating this way, right? That's the direction of rotation of the Earth. And as the Earth rotates, this lady here is moving away from sunlight. In other words, sunset. So what time would it be at sunset? Let's say 6 p.m. All right, so this lady's at 6 p.m. All right, now, here you are looking into space here. What time would it be here? Well, this is the opposite of noon, right? You're away from noon. So what time would it be there? This would be midnight, right? And this would be 12 a.m. Now take a look to see if you guys have any questions as the time is. The sun is on top of your head, 12 p.m. You're moving away from the sunset, 6 p.m. Opposite side of 12 p.m. would be 12 midnight. So this is what we're talking about, right? After midnight. You can write down after midnight. After midnight. Why is this the best time to see meteors, right? Meteor showers. All right, well, let's figure this out. All right, well, first of all, let's have a comet. We said meteor showers come from comets. So when the comets sublimate, which means they go from the ice to gas, whatever dust is embedded, the ice sublimates, goes away, doesn't melt, right? It just becomes gas. And then this dust keeps traveling around the sun. Every dust is like a little tiny planet. Keeps orbiting the sun, orbiting the sun, orbiting the sun, until, someday they all dissipate, basically. Spread out so much that you can't even see a meteor shower. So here's the orbit of the comet. Right, it's coming in this way. This is a comet. Here's a comet. And it comes in. And it sublimates, right? So we say sublimation. Now it becomes really beautiful because the sunlight and the solar wind, they make this beautiful tail for the comets and everything. But we're not concerned about the comet's tail. We're concerned about the dust. So here's the dust. As the thing sublimates, it leaves behind a lot of dust. These Italians, they can figure out where the mother lode is. Like, let's say, here is the mother lode. Look. There's the mother lode. So it's thinner and thicker at places. It's not uniformly distributed, right? Like that. It's the gravity of the planets changes the formation of this dust. Now, the Earth is going through that dust, right? So you can see the Earth after midnight, because you see these meteors at night, right? So after midnight, the Earth here, right? This is the Earth. After midnight, faces the orbit of the dust. That's why you see it best after midnight. Because you're not facing it here. The Earth is traveling this way. So the Earth is going this way. And so you don't see it on this side. Why? Because you're turning away from the Earth's direction. So it's kind of like this. If I'm sitting in a car driving like this, I see accidents in front of me. But if you're sitting facing the other way, you don't see the accidents in front of you, that's all. So because the Earth is going this way, they appear to come from this direction, and that's why after midnight is the best time to see it. So one more time, the Earth faces the orbit of the dust from the comet. So this is dust particles. There's where the dust is. So this could last for days, could be weeks. before the meteor shower is over. And when it goes through the thickest part of it, that's when you have the maximum number. That's the peak is. So the peak is that night that is listed as the maximum. When they say you see 60 an hour, that's what they're talking about. I hope I made sense to you guys. Aaron? Can you hear me, Aaron?
Yes.
Can you hang around after class, please?
Okay.
I would appreciate it. Thank you very much. And then let me see. Victoria, you still here? Ms.
Yes,
Hood?
I'm here. I had to switch phones.
Yeah, hang around after class with me too, will you please?
Okay, I'll try. I had to go somewhere, but I'll try.
Right now, it's like before 1 o'clock.
Oh, is everybody already gone?
Yeah, right now, yeah. And then I
Oh, sorry.
have Cuevas, Bowden. If you could also hang around, I'd be really appreciated. Noah, if you could hang around as well. And Mr. Sanchez. There was Noah, Guzman. Sanchez was Andrea. I'm sorry, Andrea. I didn't mean to say Mr. My apologies. And Giselle. I guess Giselle never came in today. All right, you guys have a wonderful week. I'll be here on Wednesday to help you guys out with any lab at all. I'll be here on Wednesday afternoon for office hours to help you with whatever you guys want. What else? I'm just here for you guys, right? So if you're in my lecture class and my lab class, come in anytime. Okay, I'll bid you guys farewell. You guys take care of yourselves.
Thank you, Professor. Have a nice
Bye, you
one.
guys. Thank you so much
All
for
right,
coming in.
Professor,
I
have a
really
good one.
appreciate it.
A good one.
Thanks a million,
Professor.
you guys. I really appreciate you coming in. Take care, you guys. Take care, Jesus.